Good evening, everyone. I would like to thank the Immunization Coalition for inviting me to speak on dengue vaccines today. My name is Annelies Wilder-Smith. I am the team lead at WHO for vaccine development, and I'm also the coordinator at WHO for the SAGE working group on dengue vaccines. So, do we need a dengue vaccine? Dengue is a disease of high morbidity, but relatively low mortality. About 300 million infections are estimated to occur every year, but most of them are actually asymptomatic, and probably about 100 million, still a very, very high number, are symptomatic. About 50,000 deaths are reported every year. 75% of the burden is in Southeast Asia, followed by Latin America. In Africa, the dengue problem is starting to kick off, and we all predict within the next 10 years, it will explode as much as it did in the Americas in the 1980s. Dengue has 4 quite distinct serotypes. Each of the 4 serotypes can cause the full spectrum of disease, from asymptomatic to symptomatic to severe dengue, and occasionally to death. A vast majority, about 80%, as I said, are asymptomatic. Now, it is really the order of the infection that determine the severity of the disease. In a primary infection, you can still find the full spectrum. You can also have severe disease, but it's much more likely to result in more severe disease if it is a second infection. Now, interestingly, the 3rd and 4th infections are notably milder than the 1st and clearly much milder than the 2nd infection. The relative risk of a second infection compared to a primary infection to result in severe dengue is about 2 to 3. Important for you to know, and many people get this wrong, not every secondary infection leads to severe dengue. About 2 to 4% of secondary infections lead to severe dengue. But the other way around, most of the severe dengue, about 80 to 90%, are due to secondary infections. The case fatality rate is relatively low. And with very good case management, it can be even brought far below 0.4%. But of note, during epidemic situations, the case fatality rate can be 10 times higher. And also in situations where doctors are not very familiar with good case management, the case fatality rate can be higher. As you know, it's very symptomatic treatment with hydration, and it needs to be very carefully titrated to the situation. So dengue is now listed as one of the top 10 global health threats and has seen a 400% increase over the past 2 decades, with increasing frequency and magnitude of outbreaks, most likely driven by urbanization, which are associated with increased population densities and often unplanned urban infrastructure with poor waste and water management. But we also now see an increasing geographic range due to global warming and due to the introduction of the virus to viremic migrants or travelers because of increased mobility. So, noting this problem, why did it take so long to get a dengue vaccine? And the answer lies in this graph. If you understand this figure, you really understand why dengue vaccine development is so difficult. And it's because of the immunological interaction between the 4 serotypes. So at the time when you have an infection with a single serotype, you will get strong, robust, lifelong immunity against that serotype. We also call this homotypic immunity or a type-specific immunity. But interestingly, at the time of this infection, there's also triggers antibodies against the other serotypes. But they're often, and initially, these antibodies also provide some protection against the others. But as these cross-reactive antibodies, we call them heterotypic antibodies, so non-type specific antibodies, whilst they're initially high and protect, as time goes on, these antibodies wane, and then fall below a certain threshold, and the threshold we have not yet determined, where now there is actually an increased risk of severe disease, so enhanced disease. And this time interval is it starts about 1, but really about 2 to 3 years after the infection that you now can see enhanced disease. This is another way of putting it immunologically. So with your first infection, so you are dengue naive, you have your first infection, initially you have cross-neutralizing and protective antibodies, but they drop off and you're only left with monotypic neutralizing antibodies. On the other hand, if you have a second infection, you will increase again the cross-neutralizing overall antibodies, but you keep it at a relatively high level as serotype cross-neutralizing antibodies, also with some protective effect against serotypes not yet seen by the immune system. If you just understand this, you will understand that any live-attenuated dengue vaccine will have a differential performance depending on whether the person is dengue naive or has been dengue exposed. And to make the nomenclature more easy, we use it then seronegative dengue naive versus seropositive if you've had dengue exposure. So there are 3 dengue vaccine candidates. They have a lot of similarities. All are tetravalent, all are live attenuated, but they differ in the backbone and the extent of the chimerization. So Dengvaxia was the first licensed dengue vaccine that had yellow fever as a backbone. So basically, you only had all the non-structural proteins were from a non-dengue backbone. For the Takeda vaccine, the backbone is dengue serotype 2. So the pre-membrane, so the surface proteins are inserted on the dengue serotype 2. The TV003 or also TV005, developed by NIH, currently trialed by Butantan and probably marketed by Merck in the future, has actually 3 full genome attenuated viruses, and only serotype 2 is chimerized into a serotype 4 backbone. So you see the number of dengue proteins increases with these products. Let me just briefly summarize the problems or the issues with Dengvaxia. And most of you know it, so I will just go at high level. There were post hoc analysis done by the company. So these were not results that came out of the Philippines, as sometimes erroneously is thought. So these were post hoc analysis done on the trial population using a novel antibody test to retrospectively determine baseline serostatus. And then they retrospectively reanalyzed the data, stratified by seropositivity versus seronegativity. As you see, the seropositive have a very good benefit. There's a reduction in a cumulative incidence of hospitalized dengue if you're vaccinated and were seropositive at baseline. But the seronegatives, you will see here, initially are, the curve is together, but then the seronegative vaccinated exceeds the seronegative unvaccinated, the control group. That means there's now a higher risk in the vaccinated and seronegatives to actually have a severe disease, with hospitalization being a proxy. So whilst this vaccine is very good in seropositives, in seronegatives, it actually causes harm. So this is a serostatus-driven vaccine performance, and of course efficacious and safe in seropositives, it did increase the risk in seronegatives to a similar relative risk that we see in nature, in natural infections. And WHO at the time suggested that we should do a pre-vaccination screening strategy whereby only dengue seropositive persons are vaccinated. As you can imagine, adding a pre-vaccination screening adds to the costs and complexities of this of a rollout of this vaccine, and hence we have seen a very low vaccine uptake. So the public health need for a vaccine is still unmet. How do you explain this phenomenon of the behavior of dengue? And you see here, this is the viremia measured after a single dose in seronegative, so dengue naive subjects. And you see here that only viremia is observed for dengue serotype 4. So already from these results, you can infer that this is a serotype 4 dominant vaccine. Now let's move to the Takeda vaccine that was recently licensed, given at 2 doses. The trial was done in the age of 4 to 16. And just to remember this, that the backbone is here, serotype, the dengue serotype 2. So the same study done, also looking at viremia following a single dose. And you can see here that viremia is triggered for serotype 2. That is not unsurprising because the backbone is serotype 2. So we can already see that this vaccine is a serotype 2 dominant vaccine, performs better in serotype 2. That said, there are antibodies elicited to all 4 serotypes that are even homotypic. That means serotype specific. But the proportion of these serotype specific antibodies is clearly higher. You see it in the lower bar. It's clearly higher for serotype 2 and lower for serotypes 1, 3, and 4. So we would expect, again, a different performance depending on serotypes. But the reassuring part is, and this is now the same curve as I showed for dengue, now also done for Takeda vaccine, where the vaccine performance is stratified by seropositivity versus seronegativity. And you see here the curves remain divergent. They do not cross over, showing that if you just look at the aggregate data of seropositive versus seronegative, you do not see a safety signal here. But then, of course, we need to know that this is very serotype driven as well. So I just want to show you now the results of the TAC-03, the Takeda vaccine phase 3 trial in more detail. So this trial was a double-blind RCT done in the age range of children 4 to 16. 20,000 participants were included, and this is important. 28% were seronegative, or the other way around. 72% were seropositive at the time. And it's very important to note this, that the proportion, because this will drive also your vaccine performance. It was done in 5 countries in Latin America and 3 countries in Asia, and the duration was over 5 years, according to the WHO recommendation. So it's a very well designed, very well done, rigorously conducted a study that fulfilled all the criteria. Baseline samples were taken, observation time was really long. Now, the primary endpoint was biologically confirmed dengue, and secondary endpoint included the more severe end, hospitalized dengue, DHF, and a trial-specific definition for severe dengue. Now, if you look at this, you could take all the data and stratify by serostatus, by serostate, by serotype, by age, by year. And we've done all that. But if I were to show all this, I think I would come up with 96 different scenarios. For the purpose of today, I will focus on the cumulative data over about 5 years and look and stratify by serotype and serostatus. It's quite not difficult, but there's a lot of data, but I will just try to walk you through. So this is now just looking at the clinical endpoint of virologically confirmed dengue. The overall vaccine efficacy in this trial setting with a 72% seropositivity baseline rate was 61%. On the left is now the VE in seropositives, and you see it is slightly higher than in seronegatives. This difference is less than what we saw for Dengvaxia, but you see about 9% difference. More than 10% difference. My math is today bad. And then then further on the left, you see now stratified by serotype. And you see, not unexpectedly, it performs very well against serotype 2, 80%, and also on the right in seronegatives, very high, 88%. So there's no difference in for the serotype 2. But you see that the vaccine performance was a bit lower for the serotype 1, 3, and 4. And on the right, the performance against 1 is lower than in seropositives, and against serotype 3 and 4, there's an absence of efficacy with very wide confidence intervals and with negative point estimates. These wide confidence intervals can be explained by the fact that at the time, the 5 years of this trial, there was relatively little dengue serotype 3 and 4 circulating. So you have wide intervals, and we cannot really conclusively make any conclusions except that with these data, there's absence of efficacy. Now let's look at hospitalization as a proxy for severe dengue. Here, the good news is the efficacy is overall even higher. So the overall VE is 84%. Really good news. This is what we want. We want to prevent severe dengue. We want to also protect hospitals against being overwhelmed by a lot of dengue hospitalizations. Again, the VE is slightly higher for seropositives compared to the negatives. And it also differs by serotype. Again, very high for serotype 2, both in seropositives and seronegatives. And in seropositives, you see then a bit lower, but still very high, 66, 74%, etc. For dengue serotype 4, it's 100%, but the numbers were so small, it's really not computable. And this is a meaningless number. On the right, again, the VE against serotype 1 is 78%. I think this is very encouraging. And basically 100% against serotype 2. But there was a negative point estimate for serotype 3, but again, with a very wide confidence interval. And for serotype 4, there were just not enough numbers to have any relevant statistical power. So the negative point estimates are of concern, but these results do not help us to either conclude whether there is a safety risk or there is not, or it also does not disprove a safety risk. So we are left with some uncertainty. So the key take-home messages: in seropositive persons, it protects against all clinical outcomes for all 4 serotypes. In seronegative persons, it protects well against 1 and 2, but it does not protect against 3. And for 4, we really had very, very small numbers. So now we are left with these data, and then some people say, well, just get and create more data, but we will not have more data for the next 5 years. So we now have some uncertainty. We can neither prove or disprove a safety risk in seronegatives exposed to serotype 3 and 4. Communication of an uncertain risk is difficult. We know that. It is difficult, and we do not want to have any further conspiracy theories. We also know that the public is already sensitized to the potential risk due to our experience with the Dengvaxia story. We consulted a communication specialist, and the advice given is always be transparent. Come up with the data. This is what we have. This is the benefit. This is a harm that is not totally proven. So then we considered as a SH working group a full range, every single scenario. What could you do with this vaccine from a policy point of view? And we went from everything, well, use it liberally, to use it not at all, and came to a lot of options, and then we settled to the option of recommending this vaccine in high dengue transmission settings only, but without pre-vaccination screening. So what's the rationale for use in high dengue transmission settings only? First of all, this vaccine has the highest public health impact, obviously, where there is most of the disease. It would also mitigate any potential individual risk because in high transmission settings, most of the subjects, most of the people would be seropositive, where this vaccine performs extremely well. It would also be most cost-effective use, as initially we will have finite vaccine supplies. It will also allow for a targeted rollout to allow time to develop communication strategies and to develop advocacy for the use of this vaccine. And whilst it's being used over the next 5 years, it would enable the company or academics or any program to actually generate more precise risk estimates as we have bigger sample sizes, also in seronegatives, to rule in or rule out a safety risk. And then in the future, that would then enable a broader recommendation once we have more data. And I want to explain a little bit more about seroprevalence because the recommendation WHO has given is to use this vaccine in high dengue transmission settings as defined by a seroprevalence of 60% by the age of 9. Now, simple. Seroprevalence is a proportion of seropositive persons in a population. Seroprevalence is correlated with force of infection. The higher the force of infection, the younger the mean age of peak incidence. So seroprevalence by a certain age, and we have defined 9 as this certain age, seroprevalence by any age is therefore not just a proportion of seropositive persons, it also reflects the transmission intensity or the force of infection. And therefore, a seroprevalence of 60% and above by the age of 9 is a good proxy for high dengue transmission intensity. So then what about a target age group for programmatic use? So WHO, after long consultation process, we came to the conclusion that this vaccine should initially be introduced only for children aged 6 to 16 years in programmatic settings, in settings where there's a high dengue transmission intensity, which I have now defined to you as being 60% and above by the age of 9. Within this age range of 6 to 16, WHO then recommends that they can use any of this age range, but if they want to target it more specifically, then they would choose the age where the peak, about 1 to 2 years before the peak age incidence of hospitalizations, because hospitalizations, hospital admissions reflect the likely usually secondary infections, and you want to vaccinate them before you have secondary infections and ideally after you had your first infection. Because there's still little data in pregnancy and it's a live attenuated vaccine, this vaccine should not be given to pregnant women and should also not be given to immune compromised persons. Now, this is what we state. Until the efficacy risk profile in seronegative persons for serotypes 3 and 4 has been more precisely assessed, WHO does not recommend the programmatic use of this vaccine in low to moderate dengue transmission settings. So now Australia clearly does not qualify for a high transmission setting. So what about travelers? As most travelers are actually adults, so fall below outside the 6 to 16 years interval, and most of the travelers are, as we know, seronegative. So for travelers, I've already seen various indications, coming out from various national policy bodies. WHO gives a little bit of leeway for countries to decide, but clearly we state that persons who have had a previous infection from previous travel or from previously living in endemic areas, and they return to and be exposed again, they would have a higher risk of secondary infection and more severe disease, and they would benefit from this vaccine. Now, frequent travelers, long-term travelers, migrants have obviously a higher likelihood of had a dengue infection before, so are therefore also more likely to be seropositive. Now, we do not specifically state in our document that we recommend pre-vaccination screening. Why? Because also seronegative persons will benefit. We've seen they will benefit to almost 100% against severe dengue for serotype 2, and about, I think my memory is about 80% for serotype 1. So there is still a benefit also in seronegative persons. However, travelers need to be informed that the vaccine does not confer protection against serotype 3 and 4 if they are seronegative, and that there is a theoretical risk of severe dengue if seronegative persons are exposed to serotype 3 and 4, a risk which is currently cannot be ruled out with the available data. So herewith, I would like to thank you for your attention, and I'm happy to answer any questions.